Hey y'all, it's your math teacher, Mr. Boyd, and we're back at it again today. And today we're going to be doing dimensional analysis and some advanced problems related to what we learned last time with arc length and sector area. Okay, for dimensional analysis today, you're going to want to have a calculator handy. It doesn't have to be a fancy one, just a basic calculator will do. Because what we're going to do is we're going to be trying to turn one kind of measurement into another. Now, you've probably done this a lot on a basic level, like turning feet into inches, or miles into kilometers, maybe grams into ounces in science class or something like that. We're going to look at some more complex versions of that today. So let's do it. Okay, the first thing we need to talk about is what we mean when we say things like linear and angular velocities. So linear is super simple. It's just how fast is something moving. Linear meaning kind of in a line. So for example, miles per hour is a linear velocity. Feet per second is a linear velocity. So we're measuring speed or velocity of something that's moving. Angular velocity is also velocity. It's a speed of something, but it measures the rate at which something is spinning. The most common version of this is going to be revolutions per minute, or RPMs. This is easily seen, especially if you, some of the new cars are a little bit too fancy. They don't show it anymore. The older cars would always have a tachometer in them, so you can actually look and see at what speed is my engine spinning. And then they would use that to convert with the gear ratios to figure out how fast a car is going, something like that. Okay, the basic concept, the thing that you might miss today if I don't outline it, that might be confusing, is understand that regardless of what you're typing in your calculator, the reason why what we're about to do works is because all you're doing is multiplying by 1. Let's do a relatively simple example before we get into the good stuff. So we have 225 feet. We want to know that is the same as how many yards. So whether it's an easy question or a hard question, I always set them up the same way. I write down my starting point. They've already told us that the answer is going to be yards. So I come way down over here to the right, and I'm going to write yards. And there's going to be some sort of a calculation that's going to lead me from my starting point to my end point. And so in order to convert feet into yards, I'm going to need a conversion factor. Now, do we know how many feet are in a yard? I hope so. There are 3 feet in 1 yard, if you don't know. Okay, so what we're going to do, we're going to notice feet is here in a numerator. So I'm going to have to put feet on the bottom to cancel it out. I want to turn that into yards. I'm going to abbreviate that YDS for yards. And we know that 3 feet is the same as 1 yard. Okay, now, guys, I told you, we're multiplying by 1. You go, what the heck? That's 1/3. It's not. This number right here, this fraction is 1, because 1 yard is the same thing as 3 feet. Anything divided by itself is 1. Okay, I know that's kind of a weird concept, but that actually is 1. Now I'm going to cancel my units. Feet cancels and feet cancels. Notice we wanted yards. All we have now is yards. So actually, this is just a one-step question. So to the calculator I go, 225 divided by 3, and I get 75 yards. So I'm going to come down here, 75. Now, these exact same principles, this exact same logic, is how even the most challenging of these questions is going to work. Okay? It's going to be the same thing. So if they start to get confusing, come back and make sure you really understand this example, because if you do, I think you'll be able to get the rest of today's lesson. Okay, let's take a look at these questions. All right, we're going to deal with a truck, a big truck. It has tires. Each of them have a diameter of 4 feet. I always like to stop and draw it. For whatever reason, maybe I'm just a visual learner. Drawing this out is helpful to me. And they said diameter is 4, which means the radius is 2. The tires are rotation, I should probably say rotating. They're rotating at a rate of 200 RPMs. If you don't know, that means revolutions per minute. We're going to outline that in a second. We want to know at what speed, in miles per hour, is the truck traveling down the road. Okay, so here's what I'm going to think about. At the end of this question, my answer is going to be miles per hour. Now that's a little different than the question we just did, because the question we looked at a minute ago, it started out with a linear unit, a single unit, just feet. And it ended with a single unit, yards. But in the one we're looking at now, we have a unit that is a rate. It's miles per hour. There's 2 chunks to it, which means if we're going to end up with something like this that has 2 terms, we better start out with something. Now the reason that's important, 4 feet, that's just 1 unit, just feet. But RPMs is both revolutions and minutes. And that's the reason why I'm going to start with revolutions per minute. And now it's easiest is if we think of this as 2 different questions. One in which we turn minutes into hours, that's not super hard, and one in which we turn revolutions into miles. That's going to take a little bit more thinking. Now, we get to decide which question to do first. So what I suggest, let's do the one that's easy. Let's deal with minutes first. So in my first conversion factor, since minutes is in the denominator here, I'm going to use minutes in the numerator here. And we need to turn minutes into hours. Do we know how many minutes are in an hour? I hope so. You should know that there are 60 minutes in 1 hour. So the minutes cancel out. We now have revolutions per hour. So hour matches hours. We're done with the denominator. Now we're going to focus on turning revolutions into miles. And that's where it gets a little bit fun. So here's what we got to think about. Imagine there's some point on this tire, and that tire is rotating, and it completes one full revolution, one full circle. Are we able to say how far that point has traveled? We should be able to, because if you think about it, this point has traveled the entire distance around the outside, and that distance is called the circumference. So I'm going to make a note, and this is generally true for any wheel that's spinning or anything that's circular. One revolution equals one circumference. Okay, because it's traveled around the circumference one time, which means since we know the circumference is 2 times pi times radius, we can equate one revolution to 2 pi r. And so that's what I'm going to do here. So I'm going to put revolutions on the bottom. Going around the circle one time is equivalent to going the distance of 2 times pi times the radius. Now the radius turns out to be 4 feet. Let's cancel out our units. Cancel out revolutions. Cancel out revolutions. So now what we have, our remaining units are feet and hours. We want miles per hour. We know feet per hour. Okay, so this part up here might be something you've never thought about before. Okay, and that's one that we can get by thinking. The next conversion factor you may not be able to get by thinking. It's one you just have to know. So I'm going to tell you now. Guys, do you know how many feet are in a mile? There are 5,280 feet in a mile. That will be one that you will want to study and memorize. Okay, it's good to know anyway. So let's get going. Are feet going on top or bottom? See, feet's on top here, so feet's going to go on the bottom here. That way they cancel out. So that's 5,280 feet is the same as 1 mile. We're going to cancel out the units that we can. So cancel, cancel, and then we stop and reevaluate our units. What we now have left is miles and hours. What we want is our answer is mile and hours. That's why I write it, so I understand when to stop. So what that means is we're now going to go to the calculator. And I'm going to talk you through somewhat slowly how we type this in. What I'm going to do is I'm just going to read this thing left to right. I'm not typing in letters. I'm only typing in numbers. So I'm going to do the numerators first. So I'm doing 200 multiplied by 60 multiplied by 2 multiplied by pi multiplied by 4. And I don't type in times 1 because I already know that doesn't do anything. Okay, so then I'm going to get a number. Then I'm going to consider these numbers in the denominator. Notice, all of these are in the bottom of a fraction, which means they're all division. So divide by 1, that does nothing. Divide by 1, that does nothing. I do need to divide by 5,280. And what do I get when I do that? I get 57.1. And I'd like to encourage you to always stop when you get to the end of one of these questions and ask yourself, in context, does this answer make any sense at all? Does it make sense that a big truck could go down the highway at 57 miles per hour? Yeah, heck yeah, that's what they do. Absolutely, that's a reasonable answer. Now notice, I had some extra space here. That's no problem. And you don't have to write this part at the end, but what I found for myself and for many of my students, if I don't write where I'm headed with my calculation, I often don't know when I'm done, and I often cannot figure out what to do next. So this is my little trick that helps me. This is no problem at all. A little bit of blank space never hurt anybody. So there's our answer. They asked at what speed in miles per hour is the truck traveling down the road. We now know it's 57.1 miles per hour. Let's do another one. Okay, in this one, we're going to talk about little Susie, and little Susie's going to ride her bike. If you're feeling really solid right now, this would be a great time to pause the video and try it on your own. Either way, pause the video and read the question and see if you can understand it before I start, even if you want me to walk you through it. Okay, here we go. She's riding her bike down the street. Over the course of 1 minute, she travels 200 yards. If her tires have a radius of 1 foot, what is the average angular velocity of her wheels in revolutions per minute? All right, they've been kind enough to tell me that the punchline to this whole question is revolutions per minute. Nice. And so I know that wherever I go in this question, that's how it's going to end. The question is, where do we start? So what were we given? We were given 1 minute, 200 yards, and 1 foot. Each of those is a one-dimensional unit. There's not two things, like revolutions and minutes, that's a rate. None of these are rates. They're just measurements. So we have to ask ourselves, is there a way we could put them together? And absolutely we can. What we're going to do is we're going to take these 200 yards in that 1 minute and realize, hey, if I do 200 yards per minute, so 200 yards per minute, that now is a rate unit that I can use to convert. Okay, so now we're going to get going with that. And we need to turn yards into revolutions. We were asked for revolutions per minute, and we were given this. We actually already have minutes down here. So that's good news. It means we don't have to fight with these minutes at all. The only thing we have to try to figure out how to do is how are we going to turn these yards into revolutions. So let's do a little bit of side work. Let's think about what's going on in this question. We're talking about tires with a radius of 1 foot. Just for fun, let's remember this. 1 revolution equals 1 circumference, and a circumference equals 2 pi r. And in this case, r is 1 foot. So what we know is that 1 revolution equals, and I'll actually simplify this, 2 pi feet. Now that's not generally true. That's true for this specific question because that number right there is 1. So now we can say, all right, we have kind of a link here, and we can kind of start to think backward because we want to end up at revolutions, which means at some point we have to get to feet. Currently we have yards, and it turns out we know how to turn yards into feet. So this is a little bit more advanced thing. We got to kind of think backward a little bit, right? So 1 yard is the same as 3 feet. We know that 2 pi feet is the same as 1 revolution. And you know what? I got a little sloppy. I forgot to cancel my units. Let's go back. Yards cancels with yards. Feet cancel feet. And so now what I have left over is revolutions per minute, which is exactly what I wanted. It's calculator time. Let's do this. Okay, so again, I'm going to talk you through how to type that in. I'm going to type in 200, multiply by 3, and I'm going to divide that by 2 pi. Now be careful. For some calculators, that 2 pi will need to be in parentheses, or the calculator may misinterpret it. Okay, and so I get 95.5. We're always going to stop and check and see if our answer makes sense. Is it possible that a bicycle wheel could turn over 95 times in 1 minute? I think so. Yeah, seems reasonable. And that's exactly what they asked for. Y'all, we're done. So it's not that much work. The work's not that hard, but a lot of these, in some step, there's some little bit of side work and a little bit of logic and problem solving we have to apply to get through them. Okay, now we are going to end today with a little bit of an extension question. This one's inspired by my car. I was out looking at my car the other day, and on the back, I noticed, and by the way, this is not my car. My car is a little bit cleaner than, not a lot, a little bit though. We get this kind of funny shape when the pattern that's made by the windshield wipers. And I don't know what the name of that shape is, but it's kind of an interesting shape. And I started thinking, I wonder why car companies don't advertise the size of this shape or the size of this area that's cleared off by the windshield wipers, because the bigger that is, the better you can see out of the car and the safer potentially it would be. And on the back of my car, it's a really small little wiper, which means I can't see out the back of my car very well. And I thought, oh, that's not really very good. I wonder how we could find that area. So that's what this question is going to ask of you. And here it is. The rear window wiper of my car, and this is my actual measurements, it's 12 inches long. We're talking from here, well, let's write in a color that shows up. We're talking from here to here, or you could think of it as the length from here to here. They're the exact same thing. Okay, that's 12 inches. The bottom edge of the blade is 8 inches from where the wiper arm connects to the car. That's this distance. That's 8. The wiper arm travels through an angle of travel of 100 degrees. So this is 100 degrees. And what we're asked is, what is the area of the shape that you can see through where the window was wiped? So what I'm asking for is, what is the area of this region that I'm shading right here? Now, regardless of how you're feeling about this, y'all, I want you to pause the video and give it a shot. Okay, try to get a setup. Try to figure out how we would approach a question like this. Because if we can figure out how to approach it, even if you can't actually do it, by coming with a logical approach, that's going to be, I think, a useful skill for you to start to develop. Okay, so pause the video, see what you can come up with. Here's what I come up with. The concept is pretty simple. What I start by thinking is, think if I have a whole circle and there's some sector on that circle, And then if I chop out this chunk in the middle, are you able to see how that shaded shape is the exact same thing as this? Okay, and my drawing's not very good, but that's what it is. So what that tells me is, initially I had this sector which I'm outlining here in black. And so it's a portion of that sector. It's this portion up here. So what portion is it not? Often it's easier to think in math about what is something not rather than what it is. It's missing this chunk right there. Well, what kind of shape is that? That's also a sector. So what I have here is I have a sector, and I'm going to call it the big sector minus the small sector, or smaller sector. And so I can just set up a calculation that finds the area of the bigger sector, the area of the smaller sector, subtracts the two, and away we go. So here's what we got to think about now. With that bigger sector, how do I calculate that area? So we're kind of going back to what we learned in the last lesson. If you're feeling like, oh, okay, cool, I got this, this would be another great spot to pause the video and try it for yourself, see if you can get it. All right, the bigger sector, what would I need to know? I would need to know the angle in the center. The angle in the center is 100. So it's 100 out of 360. I would need to know that it's part of the area of the circle, so it's pi r squared. I need to know its radius. What is the radius of that bigger sector, or of the whole circle? Okay, is it 8 or is it 12? It's actually neither, it's 20. Okay, so be careful. That would be a normal place people get confused, because it goes from the center of the circle here, and actually that doesn't show up. Let's try again. It goes from the center of the circle down here all the way out to there. That's that bigger circle. That's 12 plus 8, so it's 20. Minus the smaller sector. Same central angle, so 100 over 360 times pi times the radius of the smaller one, the radius of that smaller sector. Now, guys, if you haven't noticed, can you see that smaller sector sitting right here? So that's that smaller one that I've circled. I'll circle it again right here. That's the same exact little chunk. Maybe that's easier to see right down here that this is a sector. Okay, so in the area, the radius of that one appears to be 8. So we'll go with 8 squared. Now, I like to do this little trick. This is not required by any stretch, by the way, but I notice that this chunk and this chunk, both terms have that in common. I'm going to factor that out. So 100 pi over 360, factor that out. And then what do I have left? I have 20 squared minus 8 squared. Now, again, that is not even a little bit required, okay? The only reason I'm doing that, for me, it makes it easier to type it in the calculator. So here I go. What I'm going to do first is 20 squared minus 8 squared. And I get 336 when I do that. So I have 100 pi over 360 multiplied by 336. And so what I'm going to do now, I'm just going to multiply across the top. So 100 times pi times 336. And we're going to divide that by 360. And I get 293.2. Now, the classic math teacher question that we always ask you, 293.2, what? Dogs, cats, bananas, what is it? I remember my 4th grade teacher would always say, is it bananas? No, it's not bananas. There are no bananas in the question. Guys, what is it, though? Okay, we just found an area. What are our units here? Is it degrees? Is it 293 degrees? No, probably not. Area is going to be measured in something squared. It's going to be inches, so that's how many square inches we're talking about. Now, there's one thing I did in this video that I just blazed through and didn't address. Did you notice in each of these, I actually typed in pi when given the opportunity? I actually typed it in the calculator. And in the past, I've told you not to do that. Even in the last video at times, I told you not to do that. Here's the difference. Here's what's different about this lesson. Everything we did in this lesson was an applied real-world type question. Okay, it's something about trucks. It's about little Susie and her bike. It's about the windshield wipers on a car. Okay, so in the real world, we most easily communicate in decimals. We don't communicate in pi. Guys, if we said, hey, yeah, it's 25 pi square inches, we don't have a way, and not an easy way at least, of thinking what 25 pi square inches is. If you go to the hardware store and you start asking for weird pi things, like, oh, you know, I want to have 32 pi inch bolts. What does that even mean? I mean, it's very hard to think about. So in the real world, in this context, we're going to use decimals as our answers. When it's a strict math question, we're going to leave it exact, meaning we're not typing in pi. But from this point forward in this course, anytime it's some sort of real applied question, you should feel welcome using a decimal as your answer. Okay, that's going to do it for today. Hope you enjoyed it. Hope it was cool to see some applications instead of just straight math for a little bit of a change. We'll see you next time.